All right. Public. Save. All right, good afternoon. If anybody's out there, hopefully you'll be joining me soon. Let's see if anybody is posting online. All right. Hopefully people will join me soon. Let's see if this link here is actually bringing me to the correct location. Hey, I'm online. Hello, Constantina. Hello, hello. I'm online successfully, so first of all, welcome to Unit 2. Hello, Apurva. Hope I'm saying your name correctly. Hello, Jerome. Hello, Ash. Hello, Eunice. As I said, my name is Russ. As I've said to many students in the past, that's the four-letter word that I prefer to be called, is Russ. So, hello, Edward. Hello, Sosine. Hope I'm saying your name correctly here. I apologize in advance for names I might end up butchering. Let's go to my server here. So, hello Omaruyi, hello Farouk, hello Honjie. Hello to everyone. See, I have to see if I could squeeze down the delay in my stream here, but hello Eric, hello Sean. So this is Unit 2. If you're here for Unit 2, then you're in the right place. Hello Bernard, hello Prasanna, hello Cheyenne, hello, is it Sean? S-E-U-N, Sean? So yes, if you're here for Unit 2, then you're in the right place, and so am I. If you're not here for Unit 2, then you're in the wrong place. If you're here for Unit 1, that was this morning. Hello, Punitz. Where are you all joining me from? I'm joining you from the state of Maryland in the U.S. For me, it's 4:37 p.m. You should be able to see the screen that I'm sharing. So, India, New Jersey. I think we have a lot of people from India here, usually. So I've been told. This is my second time doing the office hours for Unit 2. So Nigeria, Uganda, Nigeria, Chennai. Yep, I think we often have lots of people from Africa, Nigeria, and Uganda in particular. South Africa. Hello, hello. So hopefully you guys have been able to log into your Jupyter pods. If you haven't been able to, I apologize if you were to post on the board, if you post on the board here that you're having login difficulties. It might help if you were to let me know your login name. I don't need your password, just your name, and I could try and track down login difficulties, but this may not happen until after the office hours today. It's kind of hard to track all these things down live when you're online and trying to, do something else. 2 a.m. in India. Well, more power to you for joining us here when it's 2 a.m. Taruk from Bangladesh. Oh, great. Bernard from Kenya. Timothy from Nigeria. Hello to everyone. So, first of all, yeah, right, if you can log in to your Jupyter Pod, right, this is the kind of window that you're going to see. You'll have Nipe from Liberia. Hello to you. So, as I said, this is Unit 2. Yeah, today's the 28th of September. That's our start date. We're here for 8 weeks. You have 2 weeks after the end of the program to submit all of your assignments. I think everyone who's here for Unit 2 has done Unit 1, so, this should come as no surprise to you. How long is an office hour? Well, it's going to be for 1 hour. So we'll have an office hour 4 times a week. 2 of them will start at the same time as this one. And 2 of them will be in the morning. Well, my morning. It's 8:30 Eastern Daylight Time, which would be, 12:30 UTC, I believe. That's the office hours on Tuesday and Thursday. And the office hours, on Monday and Wednesday are basically at this time, which is, what is it? It should be, I think it's 8:30 UTC. So, hello, Joshua from Kigali. Glad you could join us. Hello. Hello, Gladys. Oh. Or it's Karen, I guess. Is that also from Kigali? So you should see this screen. Up top you'll find the video links. So these are all in the, these are the links on YouTube to the videos. So these are the videos for this week. Right, your intro to machine learning, scikit-learn, predictors, how we can make our own transformers and predictors, how we classifiers, etc. There's a playlist for office hours, which, fingers crossed, soon after each office hour, well, I will add the office hour to this playlist. There's a shared folder, so these videos are also available as videos to download in the shared folder. More will be added as the weeks go on. You could find your grades under this grades tab. I think, as you all know, to pass this course, you need to get a grade, a positive grade on all of these mini project questions. If you get a grade of 0.9 or higher, well, you kind of get a certificate with a kind of distinction, if you like. The notebooks, so if you are able to log into your JupyterPod, you'll have a big button right here that should say like launch my server or something of that form. Once you launch your server, this is how you're going to find the notebooks. Under data course and machine learning, this is where you will find the notebooks for this course. Under mini projects, well, this is where you will find the mini projects, as the name suggests. So this in mini project right here is, I think it's the same one that you saw for Unit 1. Basically, it's, the introduction to the grader, how you use the grader, how you submit something to the grader. So, you could remind yourself about how you do this. The time on the links isn't correct. I will look into that here. Well, it's showing up for me in Monday. That's interesting. All right, I will double check. Apologies for that. That's probably my mistake when I was filling in the information here. I'll double check this after the office hours here. Let me make a note to myself. Double check office hour times on the schedule. I could help you with regard to concepts and questions. I could possibly help you out with concepts and questions in data science interviews. I guess my primary focus will be on the office hours. On the mini projects. So once again, what I was saying, so the mini projects, right, all right, as I said, I will check the times for office hours on the schedule. Apologies for the errors. Right, but you could try out the grader here on this mini project to remind you, about how you do this. Right, most of the questions are, might be providing some lists or a function. Like for this question here, you need to write a function that will work for arbitrary inputs. So, right, and here you want to write a function that will take some input and return appropriate inputs. One moment here. I just double checking. Yep, somehow I edited most of these links. All right. Yeah, I will again double check those things and make sure they're correct. Oh, all right. Yeah, I see my errors, but I'll fix those later. So once again, in the shared folder, so a few things I also wanted to mention in the shared folder. Again, you have the videos in the shared folder. So you could download the videos or watch the videos or download the videos from the shared folder. I made this file called Machine Learning Resources, which I posted on the World Quant website already, a link to this file. I think somebody added this link here about backpropagation in neural networks. That's fine. So I have put a few links in this folder here to some online resources. If you want to learn a lot about the mathematical stuff behind machine learning, this first book is a good resource, but it is rather mathematical in nature. I put a few more links in here about machine learning and the mathematics of machine learning, and here I had this probability cheat sheet with various concepts from probability. The last time I did this unit, people asked me about other information. I said, well, here's some Twitter accounts that I follow on Twitter. So Sean asked a question, will we be having a proper agenda given before every office hour, or would it be decided only in the office hours, like what happened in Unit 1? Well, it's probably more or less going to be driven by your questions that you bring to office hours. So, yeah, generally I'm here to answer your questions. As I said, we could go through the mini projects during the office hours. We might be doing some other things, like people were asking on the message boards, well, are we going to do some like Kaggle projects or something of that form? And we could have a look at maybe some kind of projects on Kaggle or some data from Kaggle and or other websites. There's one website which was suggested to me last time around. There's this website called Zindi, which is kind of like Kaggle, but it's more of a focus on, as it says here, the African data science community. So they have their own kinds of competitions here. One they had when I looked recently, they wanted to find some, this Swahili news classification. They wanted to find, they had NLP related things. I couldn't really help out with probably something like this. I don't speak Swahili, so I will be less useful. They had some other NLP related things, but you know, so there's this website, Zindi. There's of course something like Kaggle, which you probably are aware of. Kaggle is, you know, another website where they do competitions. Last time around, I think of course the Titanic data set is rather well known. I think I had a quick look at this real or not NLP with disaster tweets. You're trying to predict if a tweet is about a real disaster or not. Yeah, I was looking at this house price regression problem. As I said in the machine learning resources and in my post, we're not going to be talking about neural networks in this course. So I'm not going to be, say, talking about something like this. These competitions where you have like images, because, well, image processing or image classification and these sorts of things are neural network type of things. Could you clarify doubts regarding the ML algorithms and their mathematical implementation, or should we look into that by ourselves? You don't necessarily need to understand all of the mathematics behind these machine learning algorithms. I mean, of course, it won't hurt. It won't be bad if you do understand the mathematics, but you don't necessarily need to understand all of the mathematical details about the machine learning algorithms and how you implement them and solve the problems and so forth. That's what scikit-learn is more or less doing for us. Scikit-learn implements right, scikit-learn here is designed to, it has a lot of machine learning algorithms defined in them, and we're really going to be talking about how we use the tools in scikit-learn for solving these problems, for doing regression and classification and clustering and so forth. And Patrick, no, I'm not really going to be talking about deep learning. I'm not talking about neural networks at all in this course. Things like MLP. I'm not sure what do you mean natural language processing, Patrick? Will the mathematical aspects of ML algorithms be asked for data science interviews? I don't really think so, no. But the mathematical kinds of things that you might be asked in data science interviews would be more like some probability questions, applications of Bayes' theorem. You might be asked, maybe in some interviews you might be asked to compute an expected value of some random variable or something of this form, or computing a probability. Nope, multi-layered perceptrons. Nope, I'm not planning on talking about multi-layered perceptrons. We'll basically be talking about, the regression, classification kinds of problems, talk about some clustering. The mini projects, again, are available in the mini projects folder. You have one mini project about machine learning. Kind of more traditional machine learning, like classification and regression problems. And we have a project on natural language processing. We aren't using neural networks. We don't have an image data set for these mini projects or for the notebooks in this course. So yeah, more or less, it's the kind of, yeah, you might say it's the statistical machine learning, if you like. Yeah, the regression and classification kinds of problems is the focus of this course. You know, as well as some clustering. We talk about all these sorts of feature engineering kinds of problems. How do you use scikit-learn? How do you do time series, or how can you do time series kinds of problems, and so forth. Any book or link recommendation for statistics and mathematics? I will make a note to myself here about that. Links to math and statistics. And yeah, so I could find some, hopefully, well, I could look around and yeah, find some kind of recommendations for, you know, some books on mathematics or probability or statistics, these sorts of things. And we can add them into these machine learning resources here. I think this probability cheat sheet is pretty good itself, but yeah, there's lots of stuff in this probability cheat sheet here, including some interesting things that, like, yeah, about this idea of Simpson's paradox, that, you know, I could look at you know, conditional probabilities, and it can do weird things. But yeah, there's lots of things here in this probability cheat sheet. Somewhere in here they should have Bayes' theorems, have example problems. Problem solving strategies, biohazards. They have something about R if you're an R user, but I'm not an R user. So you could skip over, you know, this page more or less. Is there more to learn with respect to data science after Unit 2? Are we done with machine learning, or is there anything more to learn beyond the scope of this course? So Farouk, if you look at the shared folder, right, if you're back on the control panel, and the video downloads is in the shared folder, but also the, like, machine learning resources is in this folder, in the shared folder. You know, when you could view this folder on Google Drive itself, and which is what I'm doing here, and it's this machine learning resources file, which has these machine learning resources here. We, you know, at WorldQuant, we don't have a course after Unit 2. There is, you know, I mean, right, you know, there is, say, something like, you know, TensorFlow or PyTorch, for example, for doing neural networks. But we're not going to be talking about TensorFlow or PyTorch or PyTorch in this course. There are other things. I mean, right, you could go deeper into SQL. Right, you talked about SQL somewhat in Unit 1, but you could go in deeper into SQL. There's no SQL kinds of databases that you might want to learn about. There's something like Spark. for processing large data sets. But I'm not going to be talking about Spark in this course. So, I mean, the short answer to your question, Sean, might be, there are other things, to learn. But at the moment, Unit 2 is as far as World Quant is going. So, yeah, so as I said before, sorry I'm kind of jumping around here a bit, but day one is always interesting. Mostly the office hours are probably going to be driven by your guys' questions. And probably not this week, or maybe towards the end of this week, I could start talking about the ML mini project. But we could kind of work our way slowly through this ML mini project, because there's probably plenty to talk about. Yeah, all right. So links to resources beyond Unit 2. So yeah, I could look into some of those links or pointers to other resources as well. So, all right. So you guys have all done Unit 1. That's why you're here. As I said, Unit 2 is more or less talking about the tools which are available in scikit-learn. My first piece of advice is have a good look at the scikit-learn documentation. It's really actually quite good. It's probably one of the best documented libraries that I've used in the 30 years I've been doing programming. The documentation is quite complete, it's quite good, they have good examples, they have good explanations. If I want to learn about the linear regression class that's available in scikit-learn, well, I could read about this linear regression and what it's doing. And I could find out about the various options which are available to me when I create an instance of this class in scikit-learn. And I have a description here. I have a description of the various parameters which are available when I create an instance of this class. I could find out what this computes for me. I can have some example here. I see, if I scroll down to the bottom here, I have various kinds of examples which would use this class. So, I've learned a lot just by basically reading this scikit-learn documentation. And, it has good kind of cross links. So that's, as I said, that's my first suggestion as well. Spend some time when you learn about some new class in scikit-learn. At some point, spend a little time reading this documentation and finding out the kinds of things that you could change when you create an instance of one of these models. Same thing, something like ridge regression. It's another regression model. And, right, I could find out what kind of parameters are available that I could specify when I create an instance of this class. These are the kind of, if you like, the knobs and the levers that I, as the data scientist, am able to change to try and change the performance of my machine learning model. And again, I could read this documentation and figure out, oh, what is this parameter alpha referring to? What is this fit intercept referring to? Tolerance solver, etc. Some of these things I've never changed, but other of these parameters I have changed. And again, as I said, well, you have a example here and talking about the methods. And again, well, I scroll down here and I have some examples I could look at. Sean asks, would we be talking about open source contributions to ML libraries like scikit-learn? Well, probably not here, I mean, yeah, in principle, anybody can contribute to scikit-learn, right? It is open source. I or anyone else can, contribute. I can go to the GitHub link, right, and I could I could clone this repository, or fork this repository, as they would say. I could make my own updates and say I could open a pull request and say, hey, I have something new that I think I want to contribute to scikit-learn, or I could look at these issues and try to fix an issue and make a contribution in that way. But I wasn't really planning on talking about that in this course. I'm more of a user of scikit-learn than a contributor to the software. So, yeah, being as it's the first day, I guess you guys probably don't have many questions for me. I could go about looking at some, simple example here. Is understanding Git and working with GitHub necessary for a data scientist? I would tend to answer yes. Not so much for contributing to scikit-learn, for example, but right, you're often going to be working with other people to write software, right? And being able to work collaboratively with other people to write software, is quite a useful skill to have and to be able to do. And so, having some knowledge of Git and being able to use, Git, say, as a command line tool or in some GUI. I think I've only ever used Git as a command line tool, but there are GUIs which can help you out to do various kinds of things. This allows me to collaborate with my colleagues. I have colleagues who work in San Francisco, and I have colleagues who work in New York, and I'm living in Maryland, so we need some way of collaborating on the software that we're building, and Git allows us to do that. Right? I write something, I make changes, I push my changes onto GitHub, and my colleagues can then pull those changes from GitHub and integrate them into what they're doing. And so, these days it's not very often, let's say, that you are going to be building some software all on your own. And even if you are building software all on your own, Git and GitHub is still a nice resource to be able to use. Right? I could kind of use Git, if you like, as a backup. I write something, I push this onto GitHub, and basically I can make changes and push the changes to GitHub. Oh no, I didn't like those changes. Well, let's back up. How can I back up? Well, I could, go back and, I could back up on my Git commits, or I could go back and, download my repo from some particular state. So, yeah, I would kind of agree that, these days, knowing Git and being able to use Git and GitHub for collaboration, is probably pretty important to do. Because as I said, I'm collaborating with other people across the country. By the end of when we taught how to deploy a machine learning algorithm we built, well, we will be talking about, towards the end of the course, we'll talk some more about Flask. I think you should have heard about Flask somewhat in Unit 1. We'll talk a bit about Flask. We will go through at least the process of kind of deploying a relatively, simple kind of Flask application for, doing something like making predictions. I think last time I did this, I was using it to make predictions of house prices. So yeah, we could talk about like how you might save a model once you've created a machine learning model, then how you might, then use it and deploy something like to a website where someone else could like go to your website, input some data and get a prediction from the model that you have built. So yes, we will talk about at least to some extent, how you might go about, deploying your machine learning algorithm like on a website. That will be more towards the end of the course. Because, of course, there's all the machine learning stuff to learn in the meantime. Excuse me. I've been talking a lot already today. Talking to other students and doing other office hours and so forth. Are we working with NoSQL database like Mongo for data science, and would we be implementing it in Unit 2? We don't really have any planned material, if you like, for using a Mongo database or some other non-SQL database. We provide some data to, like for the mini projects, well, there's some data in a JSON format, which of course is one form that you might have your data for some kind of NoSQL database. But what we mostly do is, well, we read our JSON and convert our JSON into a pandas data frame. Are we going to learn Django? Probably not. I don't know much about Django myself. We might see how much free time, I use the words in quotes, free time I have in the middle of all the other things that I have to do. We'll see. What was I going to do here? So I have 10 minutes or so. Let's see, X is X is NPA range 1 to 10 in increments of. So if I make some data, and let's say y is 4 times x minus 3 plus np random, random dot random. Probably obviously misremembering. Why is this? Why is this not working here? Apologies, I was going to try and do some simple example here, and I've seem to be not connecting to this kernel at the moment. So let's see if I could re-establish my connection. Kernel restarts. Make sure size, yeah, all right. So I have some X and Y. Oh, I'm going to need to reshape this. From sklearn import sklearn linear model import linear regression. Make a new instance of linear regression, LR fit X and Y. I do LR dot predict on X. Right, using scikit-learn is generally about as easy as this. I have my data. Let's suppose I will. Let's make this noise a bit larger. Right, oh, sorry. Oh, hang on. Yeah, that's right. That's not right. What did I do here? Oh, sorry. I need to... Apologies. When I reshaped X, I changed what I wanted to do. Do the reshape here. Sorry, this needs to be reshaped. So, if you put aside my operator error right here, so I'll make some X values, I'll make some Y values, and we'll add in a little bit of noise. So I'll make some X values, I'll make some Y values, and here I'm adding a bit of noise. But from scikit-learn, you know, I import linear regression, I create an instance of linear regression, and then I call the fit method. I need to give my data to scikit-learn in the proper format, which is why I'm doing the reshape right here. Right, because scikit-learn is expecting my feature matrix, is X right here, to be in a two-dimensional feature matrix. So this is why I'm reshaping this into a two-dimensional feature matrix. At the moment, X would be one-dimensional. So I reshape my X to be in the two-dimensional format needed. I give my Y values, and this computes, you know, a slope and an intercept. You could see my coefficient, my intercept is here. Scikit-learn computes this to be about -2, which is, you know, kind of a bit different from my original one. There's a coefficient, which will be this array, this single array with one element in it. Well, it finds coefficient is about 4 in my noisy data. And in scikit-learn, I can get predictions. Right? I just need to give my data again in the correct format. So I get predictions, and well, these are my predictions I would have for my feature matrix as inputs. And of course, I could compare those to the real values. Right? These are my predictions. These are my real values. And scikit-learn, I could get a score. You know, this is a measure of how good my model is. My score right here, what is my score? My score is the so-called coefficient of determination, the R-squared value of my prediction. This R-squared value is defined in a certain way. You could find more information about how this R-squared value is defined, you know, in these notebooks, like when you talk about the metrics, right? But basically, this value right here, the closer to 1 it is, in some sense, the better. You know, the more accurate my predictions are. But, you know, this is what you will learn if you haven't learned this by watching the videos. This data set right here is just one that I made up. This data, this has no particular meaning at all. I just created some X values, I created some Y values, and I added a bit of noise to my Y values. So this particular data set has no particular meaning associated with it. All they are, you know, X and Y values. So, you know, I was just trying to demonstrate that it's actually relatively easy to use scikit-learn. And that all I really have to do is I create a model, I import a model, I create an instance of this model, I call the fit method. The fit method will compute the coefficients of the model. And if I want to get predictions, well, I call the predict method, and this is how I can get predictions from my model once I've fit it. And, you know, there's a score right here, you know, right? This is a way that I could kind of look at how good my model is. And we'll talk about, you know, more of these things as the weeks go on. So I have that it's 31 minutes past the hour, so I'm going to end the office hour here. Yeah, this is basic linear regression. This might be ordinary least squares linear regression, where the least squares I'm referring to is the metric that I'm using to calculate the error in my predictions, and therefore how the coefficients are actually selected in the fit step. So I'm going to leave this here for today, and we will pick up with office hours tomorrow. So thanks for your participation, and I will hope to see you all tomorrow. As one of my colleagues used to say, happy data science.